Now let's talk about output operations on DStreams. Now remember, the transformations that we run on DStreams are lazily evaluated. They turn old DStreams into new ones and really just record metadata at the time that we make those calls, telling Spark Streaming that that's work we'd like to do when it becomes necessary. Once we call an output operation though, that will actually trigger computation to happen. All those transformations will be executed and we'll get a result. Let's take a look at how that works. There are a few common output operations that we've used already. Let's take a look at those in just a little detail. There's print, which conveniently prints the first 10 elements of each batch's RDD to the screen. Then there's the save as files, save as text files, save as object files, save as Hadoop files. Each of those saves each RDD in the source DStream. So that's each batch creates a new RDD. In our examples, every 4 seconds, there's a new RDD. Those methods will save that RDD to that destination every single time. So that can be potentially a lot of RDDs. They can save as text, they can save as object files, or they can save directly to Hadoop. foreachRDD is extremely general and extremely powerful. That's going to let us pass in a function where we'll get to handle each generated RDD in the DStream independently. We can interact with the RDD API, call transformations and actions, and do whatever we want with that RDD on a per RDD basis. Then there's save to Cassandra. That works a lot like the regular RDD save to Cassandra, except for each RDD in the DStream, it's going to do that save operation. So the way we define the metadata and the saving that happens inside that call, we're going to have to make sure that it generates unique rows or that we're willing to tolerate upserts on each RDD in each successive batch. Let's look at a diagram of what it would look like to save that movie clickstream data we've been looking at. We have some stream that's continuously providing us with UUIDs, movie identifiers, that we're trying to process. So on the top, we see them coming in from the input stream, coming in through the receiver. We have movie UUIDs, and we simply want to save them into Cassandra. Now, those movie UUIDs by themselves are not unique. By definition, there are only so many movies, and we would expect them to get clicked on more than once. So we're going to make them unique with a click ID. That's simply going to be a time UUIDs. We're going to add a timestamp to each click to individuate it from the other clicks to make sure we don't upsert and lose events. Let's walk through the few steps of this Spark streaming application that would get this work done. Now here in the first step, we're going to show you a new feature that we haven't looked at before, which is the Cassandra Connector. This is a part of the Spark-Cassandra Connector API, but it allows us to perform arbitrary CQL queries against the Cassandra instance. We pass in our configuration object that's already telling the Spark-Cassandra Connector where to go to look for Cassandra. All that stuff happens for us, and with a session, we can execute that CQL query to create a table. It's a convenience. If you ever need to do that sort of housekeeping, you've got this object available to you. Then in step 2, we'll create our streaming context, open up our stream, again, to that text stream of those UUIDs, and then map the stream. Now the stream consists of simply one UUID after another. So each one of those we're going to convert into a Java UUID object because that's what the save to Cassandra method is going to expect. We're also, since remember in our schema, we have the movie UUID and then a timestamp to make it unique, and that timestamp is a time UUID. We're going to use a method in the Cassandra Java driver to generate a time UUID and return that from the map function. Then the RDD generated by that mapping is saved to Cassandra, and its columns mapped to movie ID and click ID. We've then saved an input stream into Cassandra, and that table will continuously fill up with the clickstream data that's coming in on the input stream. Let's look at how to aggregate some data coming in off a streaming data source stored into a Cassandra table. We've got the streaming data coming into the receiver, becoming an input DStream, which again is a list of UUIDs, movie identifiers. We then aggregate them, somehow grouping them by key and counting up the number of times they occur, and write those key value pairs into the Cassandra table. The key of each of those is going to be unique. It's going to be a movie ID. We're going to want to aggregate those counts though, and we're actually going to do that with a counter column in the Cassandra table, not by using a stateful transformation to count them up through Spark streaming. Let's look at the code. At first, we'll use that handy Cassandra connector object to create the table. Again, a nice convenient way of doing some DDL within a Spark streaming application. Then we'll create our streaming context, open up the text stream, and map the stream. Just like in the last example, we're going to take that text UUID we get in from the stream, each record of the stream, and convert it to a Java util UUID. Then we're going to pair it with the number 1. This is the map and reduce counting pattern. We pair it with the number 1 because once we see that UUID, we're saying, I'm counting this one time. I've seen it once. We'll then pass it on to the reduce by key method and add up the counts that we get. With that pair RDD that we create as a result, we'll save it to Cassandra. Notice there's nothing in the code here that says anything about updating a counter column. That's because the save to Cassandra method knows if you're saving to a counter column, it'll just do the right thing and increment the counter by the value that you're passing in. We could do the same work with the foreachRDD API. This again is the most powerful, most general thing you can do on the RDDs of a DStream. Let's take a look at how to do the simple thing with that API. We create our streaming context, we open up our stream, and then we call foreachRDD. Now foreachRDD counts as an output operation. We're passing in an anonymous function to it that takes an RDD as a parameter and does some work on it. That work is strictly in terms of the RDD API. It's as if we're temporarily out of the world of Spark streaming and just considering each individual RDD by itself. And that's what we do. Sure enough, we map that RDD, again converting the string movie ID into a Java util UUID, pairing it with a 1 to begin counting. We call the reducer and then save those things into Cassandra, save those pair RDDs into Cassandra. Again, counting on the save to Cassandra method to magically do the right thing for us with that counter column and increment it. Pretty nice that we get to do that. It avoids us having to do the stateful transformation and gives us a nice, tight piece of code that does that aggregation on a streaming input.